Take my salam. Assalamu alaikum and good evening to everyone. It is with great pleasure that I stand before you today as we gather to explore the fascinating realm of technology and agriculture, the realm of artificial intelligence and computer vision in agricultural applications. I am Mohammad Ayub Hossain Babor, Chief Coordinator SAIYN. In recent years, we have witnessed an extraordinary transformation in the way we approach agriculture. The integration of advanced technologies such as artificial intelligence and computer vision has revolutionized the agricultural landscape. These technologies are not just buzzwords anymore. They are driving forces behind a sustainable and efficient future for agriculture. Artificial intelligence, with its ability to process vast amounts of data and learn patterns from them, has empowered farmers and researchers alike. Through predictive analytics, AI can forecast crop yields, optimize resource allocation, and even predict potential disease outbreaks. It's like having a digital agronomist at our side, guiding you decisions that affect crop health, utilization, and ultimately yields. Today's seminar is a testament to the collaborative spirit that drives progress. We have researchers, experts, and enthusiasts from both the AI and agriculture domains coming together to share his knowledge, insight, and experiences. As we look into the diverse applications of AI and computer vision in agriculture, I encourage you all to engage, ask questions, and foster discussion that can lead to innovative solution-making discoveries. Well, let me start with a brief discussion on the science. Smart innovation, in short, SAIYN. SAIYN is a knowledge-based learning platform for youth where they can explore and boost their interest on smart and innovative agro-technologies for sustaining agricultural production, processing, marketing to ensure food and nutrition security. This is principally a youth-based network focusing on youth entrepreneurship and empowerment. Talk about mission and vision. I hope all of you already know a little bit of about our platform. So I'm trying to give an overview about this. Vision. SAIYN to be a driving force to connect teenagers and youth
Assalamualaikum, sir.
leaders in smart and innovative agro technologies. Engage and empower them to nurture their capabilities and contribute to positive agricultural transformation. Mission: connecting teenagers and youth through networking, engaging youth in meaningful way, empowering young people through capacity building events, creating an entrepreneurial culture among youths, seeking partnerships and collaborations to work. Today we have the privilege of hosting a prominent expert in the field, Mohammad Towfiqur Rahman. Mr. Rahman is a graduate assistant in the Department of Physical Systems Engineering at the University of Nebraska-Lincoln, USA. His previous publications are about competition in agriculture. We may remember some as computer vision system for getting mangoes in Bangladesh, microcontroller-based granular UV application attachment for rice planter, characterization of tea, Camellia sinensis, granules for quality grading using computer vision system, and so on. His contributions to the realm of AI and computer vision are highly regarded, and we eagerly anticipate his and we are eagerly anticipate in his insight as a keynote speaker. As we embark on this journey of exploration, I urge you to keep an open mind, embrace curiosity, and be ready to think beyond conventional boundaries. The intersection of technology and agriculture is a realm of limitless possibilities waiting for us to unlock its potential. Dear participants, now it's time to hear our keynote speaker, Mohammad Tawfiqur Rahman, graduate research assistant of Biological System Engineering at the University of Nebraska-Lincoln, USA. Assistant Professor, Department of Farm Power and Machinery, Select Agricultural University.
Thank you.
I need to share my screen. At first, I would like to thank SAIYN for inviting me for such seminar. And thank you everyone for joining us, the SAIYN and ambassadors, coordinators, and my faculty members, and also researchers, whoever listening this seminar. Very good morning, good evening to all. Today, I would like to share some of my experience in AI and computer vision in agricultural applications. Actually, I'm not expert on this line, but I'm trying to. And to introduce myself, I'm Towfiqur Rahman. I'm currently a graduate student from the Department of Biological Systems Engineering, University of Nebraska-Lincoln. In my history, I graduated from Bangladesh Agriculture University. My bachelor degree was in BSc in Agricultural Engineering, and I did my master's in Farm Power and Machinery from the Department of Farm Power and Machinery, Bangladesh Agricultural University. While I was a master's student, I also have the experience to work in fabrication laboratory at Bangladesh Agricultural University. After finishing my master's, I joined as a lecturer in Sylhet Agriculture University, and then I promoted as an assistant professor. Then I came to US for studying and to do my PhD here. So it's a Midwest state in United States, and one of the most popular university in the US within the biological systems engineering. So this is my current campus where I am living right now. So I would like to share a video from my department here. It will explain what the department is doing, what kind of research they are doing.
From there, and we evolved management. And what that allowed us to do is to go even further off the farm, up the supply chain. Now here we are ready to take that next leap, because it certainly goes beyond what is on the farmstead. The impacts on the farm, impacts on the supply chain are growing at a rapid rate.
The Ag Systems Technology major really prepares students for success, partly by being so well aligned with the needs of the industry, the needs related to technology and big data and a systems approach. So that's probably one of the primary reasons, but also our program provides the depth be underneath those current trends, and that depth of education stays with the person throughout their career.
It's about the agricultural systems and the integration and the importance of technology to our future. And so it's going to be a name that's going to resonate with prospective students. It's all about technology. It's all about systems perspective. And then employers also, which this department has an amazing partnership with employers here in Nebraska and really across the U.S. and really from a global perspective also. And so this is just going to have name recognition, and it's really going to convey what the intent of this academic program is.
Yeah, so today's tractors are highly sophisticated, and into the future, they're going to get more sophisticated. So 10 years from now, you could be seeing a driverless tractor working in the field, and our students need to be prepared to know how those machines work, and if there are problems, how to fix them. So our major focuses on teaching the important technologies that are involved in driverless technologies and the robotic systems of the future.
it set me up for success in making you dangerous in a lot of different areas. There's not a lot of people out there that I believe that can understand a financial sheet, but then also be able to put hydraulics onto a planter. Is you have a very high level understanding, but also you have the 5,000-foot view and the ability technically to achieve. So I view it as really bridging the gap between high level thinking and the ability to do it when it's hands on.
So our major today is really built around those three pillars: the technology that we see, the business that's critical in making sure that these enterprises are profitable, as well as the agriculture and natural resources sciences that are so crucial to make sure that the systems that we see in agriculture run efficiently, profitably, as well as taking care of the environment.
We cannot hear you, Tawfiq.
I hope you can hear me.
Yeah.
All right, so actually talking about my research and everything, I would like to share about some information. Like we are producing a lot of crops everywhere in this world, and we are in a saturated condition. Like we cannot think about grow more produces without taking any efforts. And in 2050, we will be projected about 2.2 billion people in this world. So that's a huge population to feed, and how we can improve. I mean, we that is a 50% more food demand on this world. So according to US, this information is already published. And what's the future of it? I mean, what do we need to do? So there is the need. I mean, can we go for genetic improvement to the crops or animals, or we can go for advanced technology to improve the crop production, or we can go for, we also need to think about the environment that we are using, I mean the natural resources, and we can also go for the better management. So where we need to focus on, scientists are focusing each field on their own way, and we are also using the natural resources. We need to think about it. One day the natural resources will be finished. So today since you saw that our seminar is on AI and computer vision, I have little experience on that, so that's why I will talk about it. Before that, actually my research, current research is on precision animal management, and I'm doing some computational work, like also the electronics and sensor applications to acquire data from animal and processing them to make sense. So talking about artificial intelligence and machine learning, so it comes with the machine learning. So if we see the artificial intelligence, it's a broader term. It has the data and the sense what the data is talking about. So in a broader group of techniques, it enables the machines to mimic aspects of human intelligence, like we are thinking. For example, it's robotics, natural language processing, machine vision, etc. So inside of that, we call machine learning, which learns. I mean, The computer learns from human that we prepare the data and the instructions to learn. So basically, it's a model or some kind of algorithms that improves their ability to give us output. While deep learning is a subset of machine learning, especially when we work with images like machine vision. So when we have the data set like images, so it works, especially we call deep learning. So it also works with the natural language processing and other area. So you can see the machine learning has different kinds. I mean, specifically we divide machine learning in four areas, 4 types of machine learning. So I would like to talk about the supervised learning today. So especially the classification type machine learning. So what is the process of machine learning? How we can achieve a goal from an algorithm or set of instructions. So like we have data. So for example, we have crop data. It might be some weather data and the yield or something like that. So it has some computational techniques. We have set some models, algorithm, and we can get some information from that. And most interestingly, we can give some data set that has not been seen by the model or the algorithm, and we can get outputs from that, and we can compare what's the result, what is the % of accuracy from there. So basically, for machine learning tasks, we have some set of works like we need to collect data. And then obviously it is digitized form, and then importing a data to some kind of machines like computers, and then organize some pre-processing tasks. We need to do that and explore some features from data. We need to look at the some features from the data, and then building a model and test it on the test data set from the beginning. We need to separate the data for testing also. So then evaluate the model, and we can use the model if the evaluation performance is good. And we always try to iterate over this portion. When we evaluate if the test accuracy is good, then we can go for deploying the model. Otherwise, we need to retrain or see the features, what feature we missed, what features are not important to take in the model. So that is a cyclic process here. So to differentiate the machine learning and deep learning algorithm, here we can see the classical machine learning algorithm. We have some data set to input, and there should be, I already said, some algorithm we provided to the machine, and it will train on the data set, and then it can result. Say, for example, is it a cat or not? It's an output. Say, for example, it's a classification algorithm. For deep learning process, we can give some images and have a model with the deep neural networks, and then we can see the results. So there are 3 kind of digital image processing we can say about. So why I'm talking about the images, like The deep learning model, it works with the images mostly. So that's why I'm talking about the images. And also, I will talk about the computer vision process a little bit. So that's why I'm coming here. So image processing, it's a processing of images to make sense, or maybe you can say it's processing the images to make visible to the model or the algorithm. So we have 3 levels for processing, like pre-processing, which has a little bit noise reduction, contrast or sharpening, contrast enhancement, something like that. And also for mid-level, we can segment or recognition a task from the image processing, like segmenting the foreground images from the background and also recognize what it inside in an image. And lastly, the high-level image processing, it is like making sense what the image has, what's not. So if we consider an image like this, so images are array. That's why I'm talking about this slide. Like if we take this image, so if I zoom this portion, so that is what it is. And if we zoom a little bit more, so we can find this. And considering this portion, actually it's like a table. It's like an array. So it has some numbers which represents the color, the amount of brightness of that pixels. So each individual unit is called pixels. So since it is a grayscale image, it has 0 to 2 to 255 value for each pixels. For color images like this, it has 3 different channels, like RGB. The fundamental color, it matches with each one. And I mean, if you see here, it's a blue channel, it's green channel, and this one is red channel. So combining together, it should be like this. So what, I mean, talking about the computer vision and then machine learning model, so we need to do some specific tasks, like firstly, image acquisition. We need to capture images. It can be crop, it can be animal, it can be from drone. And also there are lots of things going on in agricultural research, like having hyperspectral cameras to drone or inside a greenhouse. So taking data from camera is the most effective way to consider for agricultural research, like to predict crop yield, to predict pest attack, also for fertilizer prescriptions. So then we have image processing part. We can pre-process the image, and we can segment the object. We can remove the noise. So whatever we need to do in here, also here. But mostly for machine learning and deep learning algorithms, we don't do much image processing part. I mean, we don't need to disturb the data set a lot, because machine learning and deep learning has such powerful method and algorithms that can also detect, and it considers the noise and everything, and it automatically removes those things in their analysis. So this part is the machine learning or deep learning part. So actually what happening inside a neural network that I was talking about, the deep learning. it has some input layers, hidden layers, and output layers. And actually, it looks like the nodes, it is interconnected with each other, and it looks like a neuron. I mean, we scientists compares it with a biological neuron, because it receives the input information and passes through the hidden layer, and it computes the weights, and every time it the data passes through this neurons, and it has some outputs, and it changes, it updates the weights and bias. For example, it's a simplest linear model, y equals wx plus b. So every time the data set enters in the neuron, and to the output layer, it updates the weights and bias. So earlier I told you, like for the data set, we need to see how the model is working. So that's why we separated from the beginning. We separated the test data set to test on the model to see how it's working. And talking about the iterations, how many times, I mean, I was talking about this here. So how many times we need to feed the data set and take the outputs? So it depends on the curve, the learning curve, the loss curve, you can say. I mean, the model is, the loss function of the model is decreasing in a point. After that, it is not decreased as much as we want. And so how many iterations we need? So we can see from the graph that is my point, that I need to stop the learning my algorithm so that I can get the highest predictions, highest accuracy from this point. So this 70% is for the training data set that we have our data, and this 15 is for validation. Instantly, when training the model, it validates. So that's why we need this 15%. And after that, this percent is really unseen data. The model didn't see about this data. So what happens on image layer and convolutional, we call it convolutional neural network for deep learning. So what happens on convolutional layer? So it's an image, it's 20, 40 into 3 channel image. I mean, its height and width is 20 into 40 and the 3 channels. That's why we are calling this like, and it always, the convolutional layer, there are so many tasks. So for example, it makes a kernel. It's a 3x3 matrix here, and it passes through the images for each pixel, and it makes some results like after convoluting from this image, after passing this kernel from the image, we can have this result, and it passes. This happens multiple times, depending on our model and inputs. So we have also different kind of activation function. So for classification algorithm, the activation function like softmax is very important. Actually, if you have 5 classes in your hand, so which one is actually this one? You need to decide. The model needs to decide. So then it votes like this. So for example, you have 3 classes. One is getting 7 votes, one is getting 1 votes only, and one is only 2 votes. So 7 is the highest. So it should be category 1. The model is predicting category 1, I mean class 1. So it does like this. And most importantly, when you will see when you will understand that your model is fully trained, you need to stop. And the machine learning and deep learning, who uses that, they followed this algorithm. Like when we need to change the hyperparameters, like some activation function, the number of epochs, number of times, how many times the dataset will passes through the model. So there is also a term called learning rate. If we increase that, and there should be some problem with the model, it will overfit and it will predict wrong. So we need to increase the rate and see what happens. We need to decrease the learning rate, see what happens on the loss. And also we need to, sometimes we increase the number of epochs and to see where the training stops. Also, we uses the early stopping function to track with the losses. I show you the loss curve. It stops somewhere, right? So we can stop it automatically, that the loss is flattened. So that's why it stops. We can do like this. And after doing this, we can set the learning rate and number of epochs, and then see the validation losses increasing or decreasing, or it is lower than the validation loss. The training loss is lower than the validation loss. Then we can we need to increase the data. We can augment the data to increase the volume of the data, and we can increase the regularization. And then we can use the, we can see our data set is balanced or not. All the classes we have in our data set, it is balanced or not. So every machine learning or deep learning researchers follow this algorithm. So I can show you a hands-on experience on an example. So it will not take much time. So let me see that. So I'm in a Google Colab platform. It's simplest way to show the scripts and notebooks here. So if I show you a data set with a deep learning, simple machine learning model, I can show you here. Hopefully everyone is seeing this page, right? Please give a thumbs up.
Yeah, we can see.
Okay, so first, we want to classify some images. This data set is called Fashion Image. It has 70,000 grayscale images with the 10 categories of different clothings, shoes. For this example, I use this data set. So I'm running from the beginning. It's importing the libraries, like the basic libraries, NumPy and Matplotlib, and also TensorFlow, which is the machine learning and deep learning library, popular library in Python. And you can see all the images, example of images here. It's all some kind of t-shirts, some kind of pants, shoes. So it has 10 categories. So the data set first I'm doing here to separate it in test and train data set that I was talking about. So it's downloading the image and then separating into test and train data set. So what you can see here, the 0 label, this is the label. So for t-shirt, we label 0. For pullover, it's 2. Ankle boot is 9. So we are giving the names to the data set, to the labels, like from the beginning to the end. Like first one is 0, second one is 1. It starts from 0, 1, 2, 3, like this. So if we want to see how many data we have now in our train set, so it says 60,000. Earlier I showed you that the total number of images is 70,000. So we divided 60,000 for training and 10,000 for testing. So how many levels we have? If you want to see, this is 60,000. Some train levels. You cannot, I mean, this array. So it says first one is 9. First image is probably the ankle boot. Yes. And then how many images we have for test? It's 10,000. Test, we want to see the labels also. And then if we plot the figure, like first one, 0 means first one. So then ankle boot. And then this is the normalization of images. If we divide it by 255, that earlier I showed you, the grayscale is ranged from 0 to 255. So all we are making is we are converting the data to 0 to 1. Then we can see some examples of the data set. And the most interesting part is to building the model. Here, if you can see that we are using the TensorFlow Keras as sequential model. It has an input shape of 28 into 28. I mean the image size. And then this is the layer that we are talking about, the hidden layer with the activation function of rectified linear unit. And lastly, since we have 10 classes for our outputs, so that's why we put 10 dense layer. I already run it. Okay. So this is for compiling the model and then fitting the model with the 10 epochs. So that means that the full training data set will passes to that model 10 times, and see the loss function, it will gradually decrease and it will give us an output. So for 10 times, it will not take much. So I'll not take much time. It will take just 5 epochs to see. And this platform, everyone can use it. The students from engineering or any kinds, they can learn just basic Pythons and use this notebook as their learning platform and run this model or any kind of codes here. And Google provides us for free this using this machine. So our model is already trained, and then we can see the test accuracy, which is almost 88%. So if you feed 100 images, unseen 100 images to that model, it will accurately predict 88 of them. that it means. So if we want to predict some, we can also do that. I mean, we can also use that model for, let's see. Okay, so plotting. So this is an ankle boot, and it says it's 98% ankle boot. Earlier, I told that it gets some voting, that which one gets a higher vote, that it makes the prediction like this. So the ninth one, I mean, the ankle boot gets got 98% voting. For another one, it gets 93% voting for sneaker. So if I run this one, we can see a few more images, which has, I mean, every single images has a higher voting for their corresponding labels. So that was an example. Who wants to start in, I mean, for machine learning, to learn machine learning algorithms, they can start with that. So I will show that video. So what I am doing here, for a little bit more time I will take. So for since I said you were like, I'm doing work with animals. I set up the electronics and sensors to collect data and store them, to transmit them, and then process them. So say for example, an animal. So we have RFID tag. We don't know which animal is getting sick, which animal got any kind of disease. And we can also track them also for their feed intake, behavior, or heat stress, everything. So we are trying to develop some methods to take images, to take the respiration rate data, the body temperature data, and making them sense by analyzing with machine learning or deep learning. So it's a new for me when I came here for PhD, because I'm an agriculture engineer. I mostly worked with the crops and machinery stuff. So after coming here, I started learning for machine learning and deep learning and the way of acquiring data. So precision livestock farming, it's an interesting topic from biological systems engineering view, and it gathers live data from individual animal in a production system, and it analyzes and implements some decision support system for the management. And obviously it is for reducing the losses and increasing the productivity. In terms of crop production, we are talking about the reducing losses. So also for animals, it's the same term. And we obviously we are working for less human labor, which I mean, it requires less human labor. Current research, if you can search for research papers and other way, so mostly in my lab, I'm working with the Dept image technology, which is not the RGB image only. It also acquires the depth information of the image, and some automatic decision support system. So here also the animal tracking, we have big fields here, and tracking animals is a big concern for US. So they have some smart collars with GPS antennas, and it records the position and the body temperature, and also the weather parameters. I mean, weather parameters together. And yes, so for continuous monitoring and behavior, food behavior and drinking behavior. We also use some kind of technologies here. So this is a diagram to show all the parameters that I was talking about. So for precision animal management, the aim is to look for the heat stress, the body condition scores, sometimes to see the behaviors of mothering ability, also reducing the mortality, and sometimes it's hard to track the animal weight. So we also talk about the automated weight monitoring and behavior analysis. So thank you, everyone. That's all from my side. If you want to connect with me, then there is my LinkedIn or Facebook and my email. To learn more, or if you have any questions, you can ask through my email. Thank you.
Thank you, Mr. Rahman, for giving a valuable speech. Think great, do great, innovate for green planet. SAIYN is moving ahead with this slogan. Besides, SAIYN has a very strong organizing structure for moving forward in a very much systematic way. We have 7 more universities along with Bangladesh Agricultural University with this journey. So we hope it will be easier to bring the fruitful conclusion altogether. Dear participants, please use chat box if you have any questions to our speakers or provide comments in this discussion session. The chat box is open. If you have any question, then you can ask directly or use the chat box.
Hello, Babor.
Yes, sir.
Hello. Hello.
Yes, sir.
Can you hear me?
Yes, sir. Yes, sir, I can hear you.
I just want to talk about some points. At first, I would like to thank Mr. Towfiqur Rahman for his wonderful presentation. And he has presented some advanced technology and tools. I think these are very helpful to our upcoming potential students. For your kind information, in Bangladesh, there are some dairy farms, especially so far I know at Narayanganj. There are some dairy farms, they use the sensor systems and tracking systems of their animals. And I think this kind of advanced technology gradually is starting to use in Bangladesh. But one thing is very important, our students are not so much familiar with this kind of advanced technology. So I would like to request you how our students of our faculty can learn about the digital image processing, data mining, deep learning, and machine vision with easy tutorial. If you have any link, I would like to request you to share with the link for our students. And at last, I would also like to request you to give some motivational speech so that the student can encourage to learn these tools and techniques for their future life. And it will definitely progress our agriculture in precision farming systems. So finally, Mr. Tawfiq, I would like to thank for your wonderful presentation. Thank you.
Thank you, Dr. Rostom Ali, sir. I know there are lots of work is going on in Bangladesh for precision livestock management. It's really, it's really wonderful to working with the live sensors. Like, it's more live than crop. So I feel very confident and interesting about this research, and students needs to be more what I can say, it's more like they needs to be curious about new things, they needs to learn. So there should be some scope to learn, and there are plenty of resources for learning, like machine learning, deep learning, data mining, and also our undergraduates like from agriculture engineering, it's about the electronics and sensors, I hope. So those are combination, and they can also do work with some little projects in their project final year projects also. And I have some of the resources that I learned from Coursera, and also some open source channels. I can share all of these things. And students, I would suggest for the students to learn about some videos. Like for machine learning, there are plenty of things, but it's really difficult and hard to find which one is good for individual. So I can remember for the machine learning courses from Andrew Ng from Stanford University, the YouTube like open source platforms has the full length video of that course. The students can start learning from that, and also they needs to get familiar with the Python programming. So that's all I can say. Thank you.
Thank you. There are some questions in the chat box.
Okay.
Ishadhan says, what are the most important features that we must expect from image?
Okay, so for this question, answering these questions, it depends on what you need to do. I mean, for research, we make a hypothesis first, and then take images, and then for classical image processing like computer vision, we do have some features in our mind. If you see, for example, for crops in a greenhouse, we can see the features of like how much green colors it has in your images. Also, you can see for how many leaves you have in your images, how much background you have in your images. So it depends on what you are doing, what is your end goal for your research, and then you can set the important features from an image. And then next question. Okay, so Nusrat Jahan asked how we can elaborate. Okay, I need to elaborate how the data sets are collected in agricultural field. For agricultural field, especially, so for example, any kind of agriculture field, so you know the process of growing crops. It needs water, it needs lights, fertilizers, and weed controls, each and everything. So data collection can be any type. I can show you some example. Like for irrigation, you can set some sensors in soil. You can go for soil testing before planting crops. You can go for some kind of instant soil nutrition measurements. before planting crops. And mostly the hyperspectral images and RGB images that I was talking about, the images we can capture from drones, that is the most suitable way to collect data from agricultural feed. But it depends what kind of data you need for your research, for your study. And then I hope my answer, it answers your question. What tools we can use to start machine learning practice? So another person asked question, what tools we can use for machine learning practice? As I said, like you need to learn the basics of Python's, like data structures, how it works. It's you can say it's a common programming practice. So every programming language has the same grammar. If you learn R, if you learn C++, that's the same, it has the same grammar. So you need to learn at least one single programming language. Best is Python because it's open source. You don't have to pay for for example, if you learn MATLAB, you need to pay for MATLAB software. So for Python, we don't have any kind of bindings for that. So you can start with learning Python and then see there are lots of basic example for machine learning that I showed you in Google Colab, which is free to use. So you can start from that. The next question, method of collecting image. I already answered that question. Like it depends on how your research is set up, what is your end goal, and methods of collecting. So it depends on what data you need to collect. You can collect weather data from weather sensors like temperatures, humidity, solar radiation at the same time. And at the same time, you can take images from the drone, maybe RGB images or hyperspectral images. Thank you.
There's a question from Tanzima Akhtar. Hello, thank you for your informative.
All right.
I'm also doing my research based on deep learning and spectroscopic techniques on image processing. I already searched your Google Scholar, but didn't find. Could you share your recent research paper or anything that you are able to provide? I am somewhat interested about your lab research.
Okay, thank you so much for expressing interest on my research. I'm actually using, I'm trying with different deep learning models for my study and research, but I don't do spectroscopic research currently. I never did that. And for image processing part, I am learning it. I'm also learning it. So I don't have a current, the research paper that I'm working on. Hopefully it will be published soon. So I can share more if you email me for my lab research to I can give you more information about my lab research through email. Thank you.
Thank you, Mr. Rahman, and thank you everyone for joining this seminar and investing your value.
Just I want to say something before you finish. Yeah. So, thank you, Tawfiq. Actually, it was a very nice presentation, and it was a kind of eye-opening for all of our students joining today. So I can see the value of artificial intelligence and machine learning in coming days, not only at the livestock, in all fields of agriculture. So it was really interesting presentation. So, and I would like to thank actually SAIYN ambassadors and SAIYN actually who have actually uh, arranged this seminar. So I think it's a good knowledge sharing platform. So what Tawfiq has presented today, hopefully it will be help to other students that what kind of research are going on in the developed countries and what could be the things that our students should learn. So I think I would like to request SAIYN to arrange this kind of seminar frequently, and it will be very helpful for all of us and connecting people from the different corner of the world. So, and I'm very happy to see the number of participants today. It was more than 90 participants. So it's really nice. So hopefully we will see more of this kind of event in near future. And again, I would like to thank Towfiqur Rahman for presenting his research and give some remarks on the future direction of research in the artificial intelligence and machine learning field. So thank you very much.
Thank you, sir.
Thank you, sir, and thank you everyone for joining this seminar and investing your valuable time. We hope it's the starting of a new journey and we will go really far with your participation. We also hope that we will meet again to execute our next thoughts and plans. Till then, keep your surroundings safe and be safe. I would like to extend my sincere gratitude to our speaker who has made this seminar possible. Let's make the most of this opportunity to learn, share, and inspire each other. Together, we can sow the seeds of the innovation that will shape the future of agriculture for generations to come. Thank you, and let's begin our exploration into the world of artificial intelligence and computer vision in agricultural applications. Thank you all.